Hello, everybody. Well, this is it. You have made it to the end of your Unit 1. So today we are wrapping up astronomy. This will be your very last lesson before your Unit 1 test. So today's notes you should have already downloaded, and these will be the last thing that should be in your interactive notebook check for Unit 1 as well. So today we are going to be going over the sun's energy. A little bit of this will be a review from Friday's lesson. So if you see something that looks familiar, that's why. We just wanted to make sure we hit the high points, and then there's just a couple new things we need to go over, and then that'll be it. We'll be done with Unit 1. So your warm-up for today was basically just saying you had to answer the question, if you went to the beach, right, on a summer day, and you stayed out on the beach all day, what would happen to you if you didn't have sunscreen on? And I don't know about you guys, but if I were to stay on the beach in the summer with no sunscreen, when I came in, I would look like a lobster. I would have really severe sunburn, and I have gotten sun poisoning before, which is no fun. I obviously have really fair skin. You guys have seen me at this point. But depending on the amount of sun that you get, no matter, what your skin color, you can get sun damage from not wearing sunscreen in the summer, or really all year round. But we know from the seasons that the radiation on the earth is higher in the summer. So this says one of the effects of ultraviolet radiation. So UV rays come from the sun. That's what causes skin damage. This kid here, he's got a little bit of a sunburn. This one doesn't actually look that big, or that bad. But this pink color is skin damage that's caused from the rays from the sun. So our focus question today, how are the harmful forms of radiation from the sun deflected away or filtered so that they don't reach living things? So today we're going to talk about some of the defenses that the earth has to protect us from the sun. So the sun's energy produces electromagnetic radiation across the spectrum in the form of waves. So remember that light and radiation move in the form of waves. So these are radio waves, microwaves, infrared energy, visible light, UV radiation, X-rays, and gamma rays. Remember, this is a review from Friday. So if we just review our electromagnetic spectrum, remember that the shorter the wavelength, the more energy that a wave has, and so the more harmful it is. So shorter wavelengths, higher energy, these are going to be things like X-rays, gamma rays, and UV rays. Now the reason we're going over this again is because some of the rays that come from the sun are UV rays, ultraviolet rays. We cannot see them with our naked eye, remember, because they're outside the visible spectrum, but they are high energy and low frequency, or high frequency, high energy, and they will damage our cells. So what protects us from UV rays? Well, this is something called the ozone layer. So the ozone layer exists in our stratosphere, and our stratosphere is just a layer of our atmosphere. And we'll talk about this later on in this class. But for now, we just need to know that our stratosphere, if we look, it's right here. So it's pretty far up above us in the earth. But in the stratosphere, there's something called ozone. And the molecular formula for ozone is O3. So the oxygen that we breathe is O2. It's 2 molecules of oxygen bonded together. Ozone is 3 molecules of oxygen. And this ozone layer helps prevent as many UV rays from penetrating and hitting our skin. Now, it doesn't stop all of it. That's why we still have to wear sunscreen to protect ourselves. But if the ozone layer did not exist, we would be getting a lot more skin damage, a lot more instances of skin cancer. The ozone layer is good in the stratosphere. We want it there. But there's something called CFCs, or chlorofluorocarbons, that will actually damage ozone. And these things are found in aerosols. So think of like hairspray in compressed aerosol cans, coolants, and then certain cleaners as well. They'll get into the atmosphere. They will disrupt the O3, and they will remove that protective layer. So we don't want that to happen. Solar wind is something that we need to be aware of. It's a supersonic plasma, and plasma is just charged particles or ions. We don't really need to know that. What you need to know is that solar wind is radiation emitted from the sun, and it is harmful. If the solar wind was able to make its way to Earth and get through our atmosphere, it could kill us. or severely damage us, okay? So it flows outwards and it bathes planets in a flood of high energy particles. It's very, very dangerous, okay? Solar wind is dangerous. But why don't we die, right? Our sun emits solar wind all the time. Harmful radiation comes at the earth all the time. So why don't we die? Why are we protected? It's because the earth has something called a magnetic field. So the magnetic field comes from basically the churning in the core of the earth, and we haven't really talked about the layers of the earth too in depth, but what you need to know is that there's basically this electrical current that is generated in the center of the earth, and it causes a magnetic field to basically propel itself around our earth. And because of this, it will deflect most of the particles from that solar wind, okay? It deflects them and it can trap them as well. So the big takeaways from this lesson, all right, what you need to know is that ozone in the atmosphere protects us from UV rays from the sun, and then the magnetic field of Earth protects us from solar wind. Both of those things would be extremely harmful if they were able to reach the Earth at full force. So what would happen to Earth if the sun were turned off? So we have talked about some of the harmful effects of the sun, but what about the good things, right? If we didn't have the sun, we wouldn't be able to live on Earth, okay? Because one, we get vitamin D from the sun, and vitamin D is very important for our cellular processes. We also get food from the sun, and how is that? That's through photosynthesis. So remember, plants use sunlight to make their food, which is sugar, and then we eat the plants and we get the sugar, which then gives us energy. So without sunlight, we wouldn't have food. And without sunlight, we wouldn't have warmth or liquid water. We wouldn't be able to survive. Okay? So radiation, when I talk about radiation from the sun, this is the transfer of energy through space by electromagnetic waves. So again, on that spectrum. So visible light, UV light, microwaves, X-rays, all of that is radiation. The sun's energy reaches Earth by the process of radiation. So when we talk about radiation, we're just talking about the Earth's rays hitting the Earth. And about 50% of this energy is actually absorbed by the Earth's surface. Okay, so about 50% is absorbed, and this is what actually gives us our temperatures. Remember, we absorb more during the summer, less in the winter. And remember that ozone blocks most of the UV radiation. Not all of it, but most of it. And then some of it is reflected by the atmosphere, reflected by clouds, or then reflected from the surface back into space. We have to be aware of something called differential heating. So we need to know that the water and the land both heat differently. Water takes a lot longer to heat up than the land does. So if you think about going to the beach, if you go early in the morning, but it's the middle of summer, the sand might already be getting pretty hot. But if you walk down to the water's edge and you get in the water, it might still be really cool early in the morning. That's because it takes water a lot longer to heat up than the land does. Okay, and this is called differential heating. Water takes longer to heat than the land. And this is actually what helps moderate the climate in coastal areas, because the land is absorbing a lot of that radiation. It heats up quickly, but the water takes a long time. And then as the sun goes down at night, the land will lose that radiation very quickly, and it will cool down while the water stays warm, because it will also take it a lot longer to cool off. So if you go to the beach in the morning, the water will be cool, the land will be warm. And then once the sun sets, if you were to go and do the same thing, then the sand would be cooler and the water would be warmer, because even though the ocean took a really long time to heat up, it also takes a long time to release that heat as well. So in the winter, the ocean acts like a giant heater, and in the summer, it acts like a giant air conditioner, depending on how much radiation it is taking in. We need to be aware of conduction. Conduction is just the transfer of energy that occurs when molecules collide. So air molecules just above Earth's surface are warmed by the process of conduction. Okay, so conduction is the transfer of energy when molecules are colliding. Alternatively, convection is the transfer of energy by the flow of a heated substance. So warm air will rise, And then when the warm air gets high enough, it will then cool and sink. This creates something called a convection current. Convection ovens also use this energy. So if we think about, you probably have heard this before, that warm air rises. It's because it's less dense. So air will get heated over the land, right? Because we know that our land absorbs a lot of radiation. It heats quickly. So as the air becomes hot, it will rise up, okay, because warm air rises. But then as it reaches up into the atmosphere, it will actually cool down again because it doesn't have that radiation. It is losing a lot of its heat. But then as it cools down, it becomes more dense. So it sinks down. Once again, falls back to the earth. Then when it gets close to the land, it warms up again and then starts to rise. And these create currents that actually move our weather. So this is where our weather patterns are going to come from. We'll talk about more about conduction and convection later on, but for now, it's just something to be aware of. And then finally, the last thing we're going to talk about today, this is a review from Friday. Photosynthesis is incredibly important. We have to know why plants do photosynthesis and why the sunlight is important. So like I said earlier, without the sunlight, we would not be able to live, okay? Plants take sunlight and convert it into usable energy. The sun gives off energy all day, but we cannot use it in the form of radiation. If we were to go without food or water and just absorb all the radiation for the sun, it would do us no good. We have to eat plants in order to get energy. We have to eat plants, and we have to eat the animals that eat plants as well, because that's where animals get their energy from as well. So plants will take sunlight. They do photosynthesis, and they convert the sunlight to glucose, which is sugar, and also oxygen. So they'll produce oxygen that we breathe, right? And then that sugar, when we eat sugar, so when we eat plants, and then sugars are not just typical like table sugar. I know when I say sugar, a lot of times people think about like candy and stuff, but also like vegetables, fruit, potatoes, sweet potatoes, those things have sugar in them too that plants have converted from sunlight. So the plants convert the sunlight into usable energy, and then we eat the plants, and we in turn get our energy. So without sunlight, we would not be able to live, okay? And with that, that is the end of your Unit 1, Lesson 8. We are officially done with your astronomy unit, okay? So for the rest of today and the next couple of days, you just need to be reviewing your notes. Make sure your interactive notebooks are completed and organized. And then I'm also going to be giving you guys a study guide that you'll be working on. And if you have your notebook completed and you have your study guide completed, I would say also study your quizzes that you took on Friday. If you can do that, then you will be successful on your first test. And if you guys have any questions, like always, just make sure you let me know.